OEWaves was started in 2000 as a spin-off from the quantum team at Jet Propulsion Laboratories. We spent the first many years doing research for a variety of government institutions and industrial partners, developing photonic technologies and a unique manufacturing capability. After building a patent portfolio of over 200 claims, we geared up to deliver products that help the quantum community. Let's look at a quantum system, the ytterbium ion. The ion has a quadrupole transition at 435 nanometers with a 3 Hz line width. Should one interrogate the ion with a traditional laser whose line width is broader than 3 Hz, only a fraction of the laser power goes to the interrogation, and the uncoupled light can be a source of noise and a loss of coherence. Should the laser go on the other hand, be narrower than the line width, the probing efficiency goes up, along with the ability to do fine control of the interaction. Our ridiculously narrow line width lasers have a simple structure. We start with a commercially available DFB or a DBR laser and couple it into our millimeter scale whispering gallery mode resonator. With a resonator Q factor of up to 100 billion, the self-injection locked laser has a Lorentzian line width as low as sub-hertz. The resonator is transparent from 370 nanometers out to 4500 nanometers, so we can provide a laser at any wavelength with an available diode in that range. In some cases, we need to double the laser to meet the customer's specific needs, so we're always looking for laser diodes, amplifiers, and doublers to be able to cover all required wavelengths. Lasers are often modulated for locking to a cavity or a spectral line. Various ways to perform that modulation introduce noise to the laser output due to tuning-related power variations. OEWaves lasers modulate the light by mechanically squeezing the cavity, moving the cavity mode without changing the laser power, leading to extremely low relative amplitude modulation. The small size of the cavity allows us to do this at high speed, providing over a gigahertz scan range with a megahertz bandwidth. As we all know, size and power matter, so these lasers provide this performance in a small package. The butterfly package shown at the bottom contains the whole optical system and is included in the cell phone-sized device above it. Having a single hertz instantaneous line width is a good starting point, but many quantum applications need the laser to be stable and low noise over a longer period. The stabilized cavity on the bottom right provides better than 10 to the minus 14th stability over 10 milliseconds. With that and the gas reference cell, our lasers can be stabilized for all timescales. While line width is a nice shorthand when talking about lasers, it obscures many aspects of the laser performance. Knowing the full spectrum of laser noise helps identify sources of decoherence and speeds up system evolution. We provide a homodyne, multifunctional laser noise analyzer that's capable of measuring the phase noise spectrum of lasers with sub-hertz instantaneous line widths at a frequency offset up to 500 megahertz and relative intensity noise frequencies up to 40 gigahertz. Using photonic techniques, we have created a line of optoelectronic oscillators and voltage-controlled oscillators for signal generation in the gigahertz to terahertz range, with the lowest noise specs available for their size for demanding and emerging high-performance applications. These are complemented by phase and intensity noise characterization tools in the same frequency ranges. I want to highlight the optoelectronic oscillator in the bottom right. It contains roughly 30 optical elements in a package that's smaller than a penny. The design and development and integration of capabilities that produce that package are available to the quantum market to help miniaturize the optical systems that are needed to scale up quantum computing and create smaller clocks and sensors. Outside of the lab, OEWaves products have been integrated into vehicles, flown into space, and sailed the oceans, so they're ready to go where the next quantum application takes you. We look forward to working with you as vendors, customers, and partners in system design and commercialization to remove noise from the quantum world.